Assalamualaikum and very good evening to all viewers. My name is Rahmat Khairibi Azizan and my friends Sazwan Rupa. We will presenting our project, which is a mod 40 synchronous counter for Technic DJ project. So this is our project, and I will proceed to the introduction. Counter which advance the sequence of number of state were activated by a clock input are set to cooperate in a count up mode. Likewise, counter which decrease the sequence of number of state when activated by a clock input are set to operate in the countdown mode. Counter that operate in both up and down mode are called bidirectional counter. Modulus counter or simply mode counter are defined based on a number of states that the counter will sequence through before returning back to its original value. For example, a 2-bit counter that counts from 00 to 11 in binary, which is 0 to 3 in decimal, have modulus value of 4, 00, 01, 10, and 11, return back to 00. So, would therefore be called a modulo 4 or mode 4 counter. This also has take 4 clock pulses to get from 00 to 11. So this is a simple brief based on our project, which is mode 40 synchronous counter that will using 0 to 40. Then will be repeated back to 0, then can be continuously repeated. So for the theory section, we have discussed about the terms that used in this project, which is what is synchronous counter, synchronous counter, mode counter, T-type flip-flop, and JK flip-flop that we are used in our project. So, for design objective and specification, firstly, we decide the number of flip-flop that we use based on our project requirement. Second, we build the excitation table of flip-flop and truth table. Third, we state the diagram and circuit excitation table. Then, number 4, we obtain simplified equation using K-map. And 5, lastly, we draw the circuit diagram. Then, we're using a software to develop our simulation. So, I will introduce more on our method. For the first step, deciding the number of flip-flop. The mode number representing the frequency division obtained from the last flip-flop. It would be capable to be counting to n minus 1 before returning to 0 state. Therefore, m is less from 2n is formula to find a total flip-flop that used in this project. M is the total number of state, which is 40, and n is the total number of flip-flop used in this project. 40, which is 2 power of 6. So the total of flip-flop we are using in the project is 6 flip-flop. For the excitation table of flip-flop and truth table that we can see on screen, they are the result of the table. So you can see on the screen. For the third is state diagram and circuit excitation table. This step will show the sequence on how the sequence will help to construct a excitation table. As we know, the number of counter count will go back to first number. So it means when 0 equal to 0, 0, we'll count until 39, which is 1, 0, 0, 1, 1, 1, and then count back to 0. On the table shown, the circuit table unknown will be represent an n plus 1 state. Next, we'll obtain simplified equation using K-map. From circuit excitation table, we use K-map to determine the value of JA, KA, JB, KC until JF and KF, which is the 6 flip-flop that we use. This is the example of one flip-flop and the K-map for the JA and JK of the flip-flop. So when we receive all the value, and we will construct the circuit based on the K-map. So this is the circuit that we have developed for our project, which is mode 40 synchronous counter. This is the result using Quartus Prime-like software to simulate the counter. And this is the VHDL coding for our project, and this is our simulation progress to simulate the project. This is the output of the simulation. For this simulation, some problem that we have encountered, the output that we want to receive, it cannot be executed due to the problem on the simulation part. So what we can expect from the project is that I've shown in the screen some of the example of the wave of flip-flop Q0, Q1 and Q2. For our project, we can expect the value Q1, Q0, Q1, Q2 until Q6 will be same as K-map and excitation table. So for discussion, we design using 6 JK flip-flop. We have total of 6 bit. This is because the counter need to count from 0 to 39. After the counter count until 39, it will repeat the cycle, start from 0 again. By reset the system when it comes to 39. The design complete VHDL. We identify function of the system first, then develop the system using block diagram or schematic file. After all system functions are set up, then we convert to VHDL. Using that, we can observe of the input and output signal using entity declaration and specify the internal operation of the design using application declaration. In other words, the change in the output occur in synchronous with the clock signal. So we need to use 6 bit in our system. As a conclusion, after doing this project, we can conclude that we are fully understanding the concept and operation of synchronous counter. While designing the circuit of mode 40 synchronous counter using Quartus Prime software, we are able to learn about coding of mode 40 synchronous counter, VHDL by developing the block diagram system and convert to VHDL. We will also be able to learn about the characteristic of block diagram and schematic file for synchronous counter that we use in the system. So that's all from us, Rahmat Khair bin Aizan, CE130103, and Sajan Zulfa, CE130173. Thank you very much and Assalamualaikum.